So a number of linked rings, each 1 centimeter thick, are hanging on a peg, okay? And we know that the top ring has an outside diameter of 20, and the outside diameter of each ring is 1 centimeter less than that of the ring above it. And the bottom ring has an outside diameter of 3 centimeters. So what's the distance from the top of the top ring to the bottom of the bottom? So we want this distance, and we know that as you go down, each ring is like 1 centimeter less wide. So if we're just gonna add up, if we're gonna add up all the diameters of the rings, we're gonna do the 3 plus 20 divided by 2 times the number of rings. And since we have rings of diameter 3 to 20, then that means we have 18 total rings. So when you add up all the diameters, you get 207, but you still have to count for the intersection point, the part where it's connected. So as we can see, each connection point is it's only 2 centimeters. So it's 2 centimeters because each ring is 1 centimeter thick. So now we have to subtract 207 by the number of intersections, and there will be 17 intersections since there are 18 total rings. That gives us an answer of 173. Okay, question 2. How many ways can 6 different gifts be given to 5 different children? And each child is getting at least 1 gift. So if each kid gets 1 gift, then that means that only 1 child will have 2 gifts. So for the kid with 2 gifts, we can choose, first of all, we can choose which 2 gifts that kid gets by doing 6 choose 2, and that will give us 15. And then since there are 5 possible children that can get 2 gifts, we multiply this by 5. And then for the other kids, they will only get 1 gift each, and to assign all of those remaining gifts among the children, we'll do 4 factorial because with each kid, like one kid has 4 choices, the next has 3, the next has 1, and the last one only has 1 choice. So 4 factorial is 24, and now you have to multiply these together, and that will give us 15 times 5 times 24, that's 1,800. Okay, question 3. Yeah. So we want to find what n is, and we know that the cost of a dozen donuts is. So okay, first of all, let's let C be the cost of a dozen, and that means the cost of one donut is C over 12. And then if we do this part. If the cost of a dozen is reduced by n cents, then it will be c minus n over 12. And then if you add n cents, or if you increase it by n cents, then you'll have c plus n over 12. So you can write out an equation for this to represent this problem. So if the dozen donuts is reduced by n, then we're going to use this. So c minus n over 12 times n plus 1 plus 1 is equal to this thing, c plus, oh wait, I wrote this wrong. Oh no, I didn't. This. Okay, so basically what this equation is saying is that if the cost of the donuts is reduced by n cents, then the buyer will pay 1 cent less for n plus 1 donuts than if the cost is increased by n. Okay. Now you just have to solve out this equation and solve for n, and you'll see that you can actually get rid of the c after you expand everything. And so I'm just going to expand it real quick. And plus 1 over 12. And you can move this up into this fraction. So plus 12 actually. And then we're going to expand this side, cn plus c minus, plus n squared plus n over 12. And since they're both divisible by 12, you can just get rid of this fraction. Okay. And now you can get rid of this, and you're left with the n's. So now we can make a quadratic formula out of all of these n's. You'll get 2n plus 2n squared plus 2n minus 12 is equal to 0. You can simplify this to get n plus, divide the whole thing by 2 to get this. And then you can just solve for n. Okay, this is equal to n plus 3 times n minus 2 is equal to 0. So that means n is equal to negative 3 or 2. Since n cannot be negative, that means it will just be 2. Can I turn on my camera? I could, but it's at a bad angle right now. It's not flattering, Okay, question 4. So this problem, you just really have to do a bunch of adding and subtracting. Yes, that was an excuse. So we're going to expand this side to get x squared minus 4x plus 4. And then we're going to do this thing. I'm going to write it here. X plus 4 is equal to y squared minus 4y plus 4. Now, if you add these together, you will get x plus y plus 8 is equal to x squared plus y squared minus, minus x, 4x minus 4y plus 8. And then you can do the same thing, except you like subtract stuff. So I'm just going to rewrite this. Actually, I'm not going to rewrite it. So if you subtract this, we're going to write it here. Then you'll get y minus x is equal to x squared minus y squared minus 4x plus 4y. So now looking at this one, we can rearrange some stuff to get x squared minus y squared is equal to negative 3y minus that. Oh, yes. That. And we can continue to expand this side. And we can simplify the other side by taking out the 3. This actually turns into 3x minus 3y. So you can take out the 3 to get 3 times x minus 1. And we can get rid of this. So we know that x plus 1 is equal to 3. And then we can work with this equation. And we're going to rearrange some stuff again. Actually, I'm going to write it here. So x squared plus y squared is equal to 5y plus 5x. And that you can take out the 5 to get 5 times x plus y. And since we already know what x plus y is, we just have to substitute it in to get our answer of 15. So x squared plus y squared is equal to 15. Okay, last question. I have less than 2 minutes, but this question is just a logic question. And so, first of all, we want to find what our smallest prime 2-digit prime numbers are, our 3 smallest 2-digit prime numbers, and those will be 11, 13, and 17. And these will also be the uniform numbers. Uh-oh. The screen is not complying. Here. So our smallest prime numbers are 11, 13, and 17. And basically, when you add any combination of these two, if you choose any two of these numbers, the sums you will get are this: 24, 28, and 30. So 24 corresponds to Alice's number and Caroline's, and 30 corresponds to adding Alice's and Bryn's. Since I cannot explain this in time. But the answer is 11. So 24 corresponds to Alice and Caroline, since Bryn says that the sum of your 2 uniform numbers is the date of my birthday earlier this month. So this date is what earlier this month means. And that means that 30 has to relate to Caroline's statement, because if this is today, then that means this 30 is later, and this 24 is earlier. Not entirely sure why this meeting hasn't ended yet, but still. Anyways, today is the 28th, so yeah. If 24 corresponds to Alice and Caroline and 30 corresponds to Alice and Bryn, then we can figure out that 24 is the sum of 11 and 13, and A plus B corresponds to 13 and 17. And since Caroline is not in this thingy, in this area, then that means Caroline's number has to be 11. So that is all for today.